Hello, Assalamu alaikum. Um, my name is Talha bin Nadeem, and today we are going to discuss the topic of polynomials and curve fitting by using MATLAB. So, first of all, we will start off with the basic definitions of the polynomial, curve fitting, and maxima and minima of a curve. So, a polynomial is basically a mathematical expressions that are frequently used for problem solving and modeling in science and engineering. So I'm sure all of you guys have studied polynomials since the school. So there is nothing new in it. What we are going to do is we will see how can we solve the polynomials, how can we uh, calculate the values using polynomials in MATLAB. So we can say that in today's session we can break our session into three sections. The first one is for the polynomials, and second topic will be of curve fitting, and the third one will be for the minima and maxima. Uh, so this is what we are going to discuss today. So as I mentioned earlier, that polynomials are the mathematical expressions, and all of us has studied the polynomials. We have been studying it since the school, and today we will study that how can we use the polynomials, how can we uh, calculate the values using polynomial by in MATLAB. So let's say I have a polynomial. 2x to the power 4 plus 4 x to the power 3 plus 5x to the power 2 minus 6x to power 1. I'm sure we don't have to write 1. Then let's say we have a constant 10. So this is my function, this is my polynomial, and I want to write down this polynomial in MATLAB. So what we are going to do is, let's say I just copy it from here, and we go into MATLAB. So this is my function. Let's say this is your polynomial 1. So what I am going to do now is, how can we write the polynomial is by using an array. So what we are going to do is, we are going to define the coefficients of the variables. Means here we have a variable x1, then we have x to the power 2, then we have x to the power 3, and then we have x to the power 4, and this 10 is basically, we can say, x to the power 0. So here we will write down the coefficients of this polynomial. So let's say x to the power 4 has coefficient of 2. So I am going to write down here 2. Then x to the power 3 has a coefficient 4. I will write down as 4. Then x to the power 2 has a coefficient 5. I will write 5. Then x has a coefficient 6. So I will write down 6. And the constant, which is x to the power 0, is basically the coefficient of is 10. So this is how we define a polynomial using a MATLAB. So let's say if I run it, so here you can see now an array has been generated for this polynomial, and it is representing that the last element is basically the constant, and then x to the power 1, then x to the power, the coefficient of x to the power 2, then we have the coefficient of x to the power 3, and then we have the coefficient of x to the power 4. So now, for example, let's say I have another polynomial. Four x to the power 4 minus the 8x plus 7. So I am just copying it from MS Word to MATLAB. So now here you can see in this polynomial we have x to the power 4, and then we have x to the power 1. We do not have the terms of x to the power 3 and x to the power 2. So instead of writing it as 4 minus 8 and 7, 4 is representing the coefficient of x to the power 4, minus 8 is representing the coefficient of x to the power 1, and 7 is representing the constant, which you can say x to the power 0. Here we do not have the terms for x to the power 3 and x to the power 2. So we will not write it as this, as I have mentioned here. We are going to define the terms, and we will define it like, let's say, 0 and x to the power 3 plus 0 and x to the power 2. So here I will have to define the coefficients of x3, x cube or x square as well, which are 0 and 0. So this is how we are going to define the polynomials in case if there is a term which is not present, like x3 and x2 in the example which I have given. So you will not skip it, you will write down the coefficients as 0. So let's say I have a polynomial 8x plus 5. So I will define it in MATLAB as 8 and 5. So an array will be generated of 8 and 5. Then let's say I have another variable, another polynomial of 2x square minus 4x plus 10. So we will the polynomial for this the MATLAB representation for this polynomial will be 2 minus 4 and plus 10, means all the coefficients uh, coefficients of all the terms which are present in the polynomial. And then again here we have an example. If we have, let's say, x square minus 150, so in this term we do not have the term which consists of x. It means that the x term, the middle term of x square and constant, which will be x, the coefficient of this term is basically 0. So in MATLAB you will write it, you will not write it as 6 space minus 150, you will write it as 60 minus 150. So this is how polynomials are defined in MATLAB. Moving forward, next we have is basically the topic that how do we basically calculate, how can we calculate the value by using a polynomial at particular point. Let's say I have this polynomial. This is the same polynomial which which I have already explained you. So let's say this is the polynomial, 4th degree polynomial, and I want to calculate the value at say x equals to 4. So this is what I want to calculate. So what I am going to do is I am going to use the command of polyval, and here in this this is the MATLAB built-in function, therefore it will be in lowercase, and there should be a parenthesis, and inside the parenthesis there will be input arguments. There are 2 input arguments in the polyval function. The first one is basically the vector, the polynomial in which you want to put the value x equals to 4, and x is basically that number, that value at which you want to calculate the value. You want to calculate the value of y, or you can say f of x, by using the polynomial which you have mentioned here as p. So let's say I want to save this answer in y1, and I'm mentioning it that x1 is basically 4. By using the polynomial p1, so I will write here p1. It means that whatever the value I will define after comma, this value will be put in this polynomial, and the value will be calculated and stored in y1. So when I mention x1, so here you can see that the value has been calculated. So let's say if I mention We are all in CNC here. So this is what the value is. And if I remove the output suppressor from x1, the x value and y value is shown here. So this is how the values are calculated. And let's say if we want to calculate the values on number of variables, let's say I want to calculate the values at x from x1 till 10 by using the polynomial p1 in polynomial p1. So I will use the same command polyval, and there is nothing which needs to be changed. I will simply run it, and what will happen here is that it will first put the value 1 and it will calculate the value of y by using this polynomial. Then it will put x value 2 and it will calculate the value of y. Means the operation will happen element by element. So this is how we can solve the polynomials. We can determine the values using polynomial with the help of polyval built-in function of MATLAB. I hope it is clear to all of you. So here I have also attached an example in the lectures. Next we have basically the roots of a polynomial. So what do we mean by roots of a polynomial? So let's say, for example, let's say I have a let's say I have this this quadratic equation as a polynomial. So the roots will be the value of x which I will obtain. So let's say with the help of by solving this I will get two answers. The first will be -1 and the second one will be 3. Here it means that whatever the highest degree of a polynomial is, that much amount of the roots you will get in the solution. Means let's say if I talk about this polynomial in which the highest degree of polynomial is 4, for this polynomial the solution set will contain the 4 values of x. And if I have a variable, if I have a polynomial which consists of the highest degree of a polynomial in that expression is, let's say, x to the power 5, then I will have 5 values of x in a solution set. So this is what we meant by roots of a polynomial. So let's say I want to determine the roots of a polynomial. So for that function, for that purpose, we have a MATLAB built-in function roots. Since it is a MATLAB built-in function, it will be defined, it will be written in lowercase, and there will be a parenthesis, and inside the parenthesis there will be an input argument. and in this function we have only one input argument, which is which will be your polynomial, and your polynomial should be in raw vector. So here let's say if I measure I define my variable as let's say p1, and it will be 1, -2 and -3. Since it is a quadratic equation, the first coefficient is of x1 x to the power 2, which is 1, and the second coefficient is for x to the power 1, which is -2, and the third coefficient will be your constant. So this is what my polynomial is. Then let's say I have used the roots function, and I will save the answer in, let's say, roots1 variable, r1 variable. Since roots is a MATLAB built-in function, so it will be in lowercase, and there will be parentheses, and inside the parentheses you will enter the input arguments, and here the input argument will be your polynomial, which is in this case p1. So I will run it, and here you can see this is the roots of a variable. So as I mentioned here, that for this polynomial I will get two roots. First one x to the power x equals to -1, and then the second root is x equals to 3. So this is what I'm getting here, and here you can see that the programming behind the roots variable is such that the answer of the roots by using a roots function, it will generate a column matrix, and the polynomial which you are entering, it should be in a row matrix. The answer, the roots which the MATLAB will calculate and it provides you, it will be in a column matrix. So this is what you need to be careful about in roots function. So let's say we do another example, and I'm using the same function which we have been using it, the x to the power 4 function, and let's say I define the polynomial 2, 4, 5, -6 and 10. Then I will save its value in R2. We will use the function of roots, and I will mention P2 here. Since it is a 4th degree polynomial, means that the highest value of x is 4 in this question, it means it will have 4 roots. So when I solve it, so here you can see that 4 roots have been generated, and all of the roots are imaginary, means this polynomial does not contain a real solution. So this is how the roots are calculated. The roots can be calculated by using the MATLAB's built-in function roots. So I have again attached an example in this question. So another thing which I will like to add here is that when we know the roots, we can write the function in the form of roots as well. For example, if I want to write the solution, the function this f of x, so instead of writing it like this, I can here we have two solutions, first -1 and second 3. So I will write it as x, and whatever the sign over here is, I mean it will be like minus, and whatever your solution is, minus, and whatever the second root is. A and B are basically your, let's say this is your A and this is your B. So the function will be, you can write the function as x plus 1, x minus 3. So after solving this equation, instead of writing this relation, we can write it in the form of roots as well. Similarly, we can do it for power 4 and power 5 polynomials. I have attached an example in the lecture here. Okay, so next is basically the function of poly. Poly's function is basically to calculate the polynomial by using the roots. And let's say if I use this relation, this polynomial, and I define it as my f of x is basically, or you can say the roots are let's say 6.5, 4, 2.3, minus ka 1.2, and 0.5. So this is what the roots, let's say we do not know the polynomial, we only know the roots, and so I defined the roots in an array. So what I am going to do next is, in order to calculate the polynomial with the help of these roots, I am going to use the poly function. And since it is a MATLAB's built-in function, so we will say that so it must be in lowercase, and there will be a parenthesis, and inside the parenthesis there will be an input argument, and in that input, and we have only one input argument in this function, which will be the array of the roots, and this array can either be a raw vector or a column vector as well. So I will just use the raw vector here. So let's say I calculate a polynomial, and by using a poly function, the roots are in R1. So when I run it, so here you can see, so this is what my polynomial is. So here you can see that we have 1 2 3 4 5 6 terms, means the terms are 6, but the highest power will be, we will start from here, x to the power 0, x to the power 1, x to the power 2, x to the power 3, x to the power 4, and x to the power 5. So this is a fifth degree polynomial expression. So here you can see, okay, so this was my polynomial. Again you can see 1 minus ka 12.1, 40.59, here 45, 40.59, and the next term is minus 17.015, and so on and so on. So this is how you can, so we have studied so far we have studied polyval function, we have studied roots function, and we have studied poly function. So this is what we have studied so far. So again an example has been attached in the lectures. So next we have the addition, multiplication and division of the polynomials. First of all, we will talk about the addition and subtraction. The polynomials can be added and subtracted just like we have done the addition and subtraction using an arrays. So we do not have we will not have to learn anything new regarding the addition and subtractions. Whatever we have studied in the classes regarding the addition of arrays, so that knowledge, that previous knowledge will be utilized for the additions of polynomial. For example, I have two polynomials. Let's say this is my first polynomial, and let's say this is my second polynomial. First polynomial, and this is my second polynomial. So I will define P1 like 2, 4, 5, minus 6 and 10. We have studied, we have already learned how to write a polynomial, in MATLAB, and for P2 we will define it as 1, minus 2 and minus 3. So these are the polynomials which I want to add. So what will happen here is, if I execute it, so if I execute it, let's say that the resultant will be P1. If I add them, then execute it. Now here you can see an error has been generated, which is mentioning that the matrix dimensions does not agree. It means that the order of these two polynomials should be same in order to carry out the addition and subtraction of a polynomial. So what do we mean by making the order same? Means that, let's say the polynomial 1 has the highest degree which is x to the power 4, then the polynomial 2 must also have the expression which the coefficient of x to the power 4. So let's say its coefficient for x to the power 4 and coefficient for x to the power 3 needs to be added here. So since there were no coefficients, so I will write it as 0. So here I will have to mention that it should be 0 and 0. Now this addition can be carried out since the dimensions have been same. So when I execute it, so see what has happened here. It has carried out an element by element operation. 2 and 0 has been added and the resultant is 2. Then 4 and 0 has been added and the answer is 4. Minus 6 and minus 2 has been added and the answer is minus 8. 10 and minus 3 have been added and the answer is 7. So this is what my resultant polynomial is. Means it will have the constants have been added, the x to the power 1 values have been added, x to the power 2 values have been added, x to the power 3 values have been added, and x to the power 4 values have been added. This will be my resultant polynomial. Means 2x to the power 4, 4x to the power 3, 6x to the power 2, minus 8x and 7, which is your constant, or you can say 7x to the power 0. So this is how additions and subtractions can be carried out. Let's say if I want to carry out the subtraction as well, I define another variable p4 and I define it as p1 minus p2. So this will be my resultant vector when I subtract them, resultant polynomial when I subtract them. So whatever the knowledge we have acquired regarding the array addition and subtraction, that previous knowledge will be utilized for the calculation for the addition and subtraction of the polynomials. The only thing which you must remember is that the order of the polynomials in order to carry out the addition and subtraction, the order must be same. Means if the polynomial 1 has 5 element, then the polynomial 2 should also have a 5 element. In case your some polynomial does not contain any term, which in our case was x to the power 4 and x to the power 3, we will write it, but we will write it with the coefficient 0. So I hope it is clear to all of you. And this addition of zeros over here, this is basically called padding. And an example has also been attached, which you can solve it when you are practicing it. And next we have multiplication of polynomials. So for multiplication of a polynomial, we have a function conv, conv. Since it is a MATLAB's built-in function, therefore it will be in lowercase and there will be some input arguments inside the parentheses as well. The input arguments in this function, there will be 2 input arguments, and these input arguments will be the arrays of your polynomial. Let's say I have a polynomial p1 and a polynomial p2, and I want to multiply it by using the help of by using the conv function. We can multiply it, and let's do the example. It will be much better to understand with the help of example. So let's say I want to multiply them. So I will use the conv function, and I want to multiply polynomial p1 and polynomial p2. So I will mention p1 comma p2. The polynomials have already been defined, and what I will do is I will simply use the conv function, and I will define the input arguments. So when I execute it, so here you can see this will be the uh, expression for the polynomial, and here you can see that in this function the highest power was basically 4, and in this function the highest power was basically 2. So the after multiplication, the polynomial which you will get, the degree of the polynomial, its degree of the polynomial will be equal to the highest power of polynomial 1 plus the highest power of polynomial 2. So I write it as degree of polynomial will be the highest power of p1 and the highest power of p2, which is 4 plus 2 equals to 6. And here you can see this is a constant x to the power 0, x to the power 1, x to the power 2, x to the power 3, x to the power 4, x to the power 5, and this is our x to the power 6. But again, the some of you may be concerned that why it is mentioning x to the power 0 and x to the power 8, because I have carried out a multiplication for x to the power 4 and x to the power 4. So let's say if I remove these and I remove them as well, and when I run it, so the additional zeros now have been removed. In previous example, what we did was we multiplied with x to the power 4 and x to the power 4, means 4 plus 4 should give you 8 terms, and this is what was happened over here. It was giving you for the polynomial of 8 degree, but when I remove them for multiplication, it is not necessary that the order should be same, but for addition and subtractions the order should be same. So this will be my answer. So again, we learned an important thing here, that for addition and subtraction, the polynomial, the order of the polynomials, the order of the array should be same, but for multiplication, for the conv function, the order is not needed to be same. Okay, now moving forward, next we have okay, another important thing here is, let's say I want to multiply more than 2 polynomials. Let's say I have another polynomial p3. So let's take this as a p3, means we have 3x to the power 6, 15, x to the power 5, 0, x to the power 4 minus 10, x to the power 3 minus 3, x to the power 2, 15, x minus 40. So this is what my third polynomial is. So again I defined P3 and it will be 3, 15, 0, minus 10, minus 3, 15 and minus ka 40. So now I have 3 polynomials and I want to multiply them. So what I am going to do is in conv function we can only multiply 2 polynomials. So what I need to do is in order to multiply the third polynomial, I will have to define another polynomial, let's say P6, and I will have to use a conv function again, but this time it will be on P5 and P3. P5 which is the resultant after the multiplication of P1 and P2, and P3 is your this polynomial. So what we learned here is that we can multiply 2 polynomials by using the conv function repetitively. So when I execute it, so here you can see this was my P5, the result after the multiplication of P1 and P2, and this is my P6, the resultant after the multiplication of P5 and P3. And again here you can see that there are 13 terms in this polynomial, means that it consists of basically it is a 12th degree polynomial, and it will be a 12th degree polynomial because the P5, the degree of polynomial for P5 is 6 and the degree of polynomial for P3 was also 6. So the resultant, which is P6, the degree of polynomial will be 12. By the word degree of polynomial, it means that the highest power in the polynomial, that it means that the 12 will be the highest power inside the polynomial. So I hope it is clear to all of you that how can we add, subtract, multiply the polynomials. Next, an example has been attached which you can solve at your home. Next we have the division of a polynomials. For division, polynomials can be divided in MATLAB by using a deconv function, and since it is a MATLAB's built-in function, so it will be in lowercase, and there must be some input arguments as well, and there will be 2 input arguments, and the input arguments will be basically your the numerator and denominator, means the polynomial which is at numerator and the polynomial which is at denominator. The first polynomial will be the numerator and the second polynomial will be the denominator. Again, by the word polynomial, it means that we are talking about the coefficients of a polynomial. Another important thing here is that in deconv function, we not only that we will give 2 input arguments, but we will also have 2 output arguments as well. The first output argument will basically contain the quotient polynomial, and the second output argument will contain the remainder polynomial. By the word quotient and remainder is basically when you basically divide a polynomial, uh, quotient is representing whatever the answer you get after division, and remainder is whatever the remainder is. Uh, so this is a new thing here. Although we have studied such commands in previous classes, uh, but in this topic, such commands, this is the first of this command of such commands. But again, it is an important thing that you must learn, that how to write, how your inputs are given and how your outputs are obtained. So in division we will basically obtain two outputs. The first output will be the quotient and the second output will be the remainder, and it does not mean that you have to use q and r as a variable. You can use any other variable as well. So let's say I'm talking about the division now, and I want to divide P1 by P2. I will have to define two outputs. The first output will be quotient and the second output will be your remainder. When I execute it, so here you can see this is what my quotient is and this is what the remainder is. Means that the quotient is 2x square plus 8x plus 27 and the remainder is 72x plus 91. Means the polynomial 1 and polynomial 2 are not perfectly divisible. There is some remainder, and if these polynomials were perfectly divisible, in that case the remainder would have been equal to 0. So this is what the division. This is what the division. Let's say we discuss another example. These are two polynomials: 2x to the power cube, 9x to the power 2 plus 7x minus 6, and I divided with x plus 3. So I define the coefficients of these variables and I multiply and divide it. And again, here you can see it is not necessary to use q and r as a variable. You can use any of the variable. But the important thing is the first variable will be the quotient, means whatever you get after the division, and the second variable will be the remainder. And here in this case you can see that all the values are equal to 0, 0, 0. It means that these polynomials were means this P1 u, this u was perfectly divisible by v, or you can also say that v was the root of a polynomial u as well. That's why it was a perfectly divisible. So this was all about the addition, subtraction, multiplication and division. So we have studied the addition of polynomials, we have also studied subtraction of polynomials as well. We have also studied multiplication of polynomial, and then we have also studied division of polynomials. Now the next topic is basically the derivatives of a polynomial. In order to determine a derivative of a polynomial, we have a single MATLAB function which is of polyder. So again, let's say I will use the same polynomials P1 and P2. These were my polynomials. So I want to determine the derivative of, let's say, P1 and the derivative of, let's say, P2. So I will use the function of polyder. Since it is a MATLAB's built-in function, it must be in lowercase, and there should be some input argument inside the parenthesis. The input argument in this case will be an array which should consist the coefficients of the polynomial. So here, let's say I'm talking about derivative of polynomial 1. I will define it as polyder. I will use the MATLAB's built-in function polyder, and inside the parenthesis I will define the polynomial P1. So when I execute it, so here you can see this is what the resultant this is what the derivative of the polynomial P1 is. So here you can see, when I am talking about the derivative of a polynomial, and let's say this is my function. I guess we have used the same function, yes. So its derivative will be eight x cube plus 12 x square plus 10 x minus का 6, and this will be the derivative of function. So again, here you can see that this is the same result which I am getting by using the polyder command. So I hope it is clear to all of you. Similarly, I can use the same function for the derivative of polynomial 2 as 2. I will write it as polyder, and again inside the parenthesis I will define the polynomial for which I want to determine the derivative, and when I execute it I get the result as well. So this is how the derivatives for a polynomials are calculated. Okay, now let's say I want to determine the derivative of a polynomial, but by using derivative of a polynomial when P1 is multiplied with P2. This is what I want to calculate when P1 is multiplied with P2. So here this is the case of UV, means we have studied this derivative of UV relations, derivative of UV formula in the intermediate level. This is what we are going to do. This is what we want to do. We will determine the derivative when two polynomials are being multiplied. For that case as well, there can be two methods. The first one is that we use a conv command to calculate the product of this P1 and P2, and then use the similar polydare function. And the let's say P3 conv P1 comma P2, and then the derivative of the resultant will be polydare of P3. This will be my resultant. But let's say, I mean, you can calculate by using it by multiplying the polynomials and then calculating the derivative. But if you remember, at intermediate level you have studied some formulas regarding the UV, regarding the multiplication of a polynomials and then taking the derivative. The relation which was like u and the derivative of v plus v and multiplied with the derivative of u. So this is what we can also do directly in MATLAB as well. And for such cases, I will again use the function of polydare. But inside the input argument, instead of defining only one polynomial, I will define two polynomials. The first polynomial will be my u and the second polynomial will be my v. This is what you have studied in intermediate level. P1 and P2. So when I calculate it, so again here you can see this is my this will be my resultant, this will be my answer. So we have studied so far two things, that polydare command can be used for two ways. The first is to determine the individual derivative of a polynomial, and the second is to determine the multiplication of two polynomials and then the derivative. And for both cases the polydare command will be used, but the only difference will be that we will have in the first case we will have, when I want to calculate the derivative of a one variable, the input argument will be the only polynomial for which I want to calculate the derivative. But when I am talking about the multiplication of two polynomials and derivative, then I will enter two polynomials in the input argument. So it will calculate the same thing which you have studied in intermediate level, which was like the derivative of uv, and it will be, let's say, uv ka derivative plus v and then u derivative. So this is what has happened by using this function, by defining two variables, two polynomials inside the polyder function. Now we have also studied another thing in intermediate, which was related to the division of u and v. And for that case, the relation was like this, divided by v to the power 2. It was like v square. So we can also calculate u upon v function as the derivative for u upon v as well. For such case, it will be like so. Let's say derivative will be like polyder p1 comma p2. But again, and the thing to remember here is, when I'm talking about a multiplication, I will define only one variable as an input as an output argument. But when I want to calculate the division u upon v, derivative of u upon v, then I will have to define two output arguments. The first output argument will store the value of your numerator, the coefficient, obviously the coefficients of a polynomial of your numerator, and the second one will store the coefficients for the polynomial of denominators. So let's say I define an array here, the first one, and again it is not necessary to use n and d to represent the numerator and denominator. When I execute it, here you can see, so this will be my numerator of a derivative, and this will be the denominator, which was v square of the derivative. This was my numerator and this was the denominator. So the result of u multiplied with the derivative of v minus v multiplied with the derivative of u will be stored here. I guess it was the other way around, v multiplied with u derivative and then u multiplied with v derivative. I guess it was like this, if I remember correctly. So this is how the polyder command can be used. So we have studied that how can we use the polyder command, and we have studied again and examples have been attached in the lecture, which you can solve and practice at home. So we have studied a polyder function, and we have studied a polyder function for three cases. First one is for derivative of one polynomial, and the second is for derivative of u multiplied with v, and third for derivative of u upon v. So this is what we have studied so far regarding the topic of polynomials and curve fitting. So we will start the I hope it is all clear to you. We will start the curve fitting topic in next session.